The innate immune response consists of the first and second lines of defense our body has against pathogens and provides a bridge to the third and final line of defense. There are three functional roles of the innate immune response. First, provide a physical and chemical barrier to the pathogen. Second, initiate an immediate response to the pathogen. This involves the cells of the innate immune response and is our second line of defense. The third goal of the innate immune response is to prime the adaptive immune response, the adaptive immune response being our third and final line of defense against pathogens. So let's start with the first goal, barriers. As you listen to my videos, you'll find out that I'm actually a bit of a history buff. And the reason for this is that when we think of history, we're actually thinking about war most of the time. Who's fighting who and why? Well, immunology and microbiology isn't that different. Just in this case, instead of fighting for the crown, we're fighting for species survival. So, back to barriers. In feudal times, we built castles. Why? Castles made kings feel safe. Castles had excellent barriers. They had specific entrances that could be guarded more heavily to keep any nefarious characters away from their king. Well, your body isn't all that different. Your body is basically made of barriers, and while we don't generally think of them as a part of the immune system, they definitely are. So think of your skin. Your skin is made of epithelial cells, and epithelial cells create tight junctions. All of these are barriers that keep pathogens from getting in contact with your vital organs. The same can be said about the endothelial cells and epithelial cells within your body as well, like those that line your gastrointestinal tract or the vasculature of your blood vessels. All of these are physical or mechanical barriers. And just like in feudal era, people did need to be able to go into the castle. They needed to bring in supplies. They needed to do business with the king. We need to do business with our outside world. We need to be able to breathe, see, eliminate waste. All of these functions can't happen if we don't have sites of entry and exit. But all sites of entry and exit are potential vulnerabilities. So we need to guard them more closely. So we can do that with more physical barriers like cilia. Cilia synchronously beat in your respiratory tract, always beating upward toward your mouth, literally batting away pathogens as if they were baseballs. But there are also chemical barriers too. Like, for instance, there's lysozyme in nasal secretions. There's also amylase in your saliva. All of these things also move. So, for instance, there's fluid like mucus and urine in the urogenital tract. All of these things wash away microbes that might be present. Another chemical barrier is actually a pH change, and I like to call it pH whiplash. So think about your gastrointestinal tract. The pH in your stomach is about a 3. The pH in the intestine is about an 11. There are very few organisms on this planet that can survive and thrive in these two vastly different pHs. So by moving from this highly acidic pH down to this very basic pH throughout the journey of your gastrointestinal tract, your body is actually protecting you, as most of these pathogens would die along the way in environments that are not hospitable to them. Now, if barriers are so great, why do we even need an immune response? Well, because no barrier is impenetrable. So while you've been picturing this nice, happy little castle, what your body actually looks like is this: a castle under siege. Why? Because we are constantly surrounded by and bombarded with pathogens. And just like this castle wall now has some holes in it, we can get breaches in our barriers. And when that happens, it's time to move on to goal number 2 of a functional innate immune response. And that is to immediately respond to any pathogens that happen to get beyond our quote-unquote castle walls. So how does this work? Well, I have a 4-year-old son. Now, like most 4-year-old boys, my son is constantly running around and playing outside, and he's not the most coordinated yet, so occasionally he falls down, and when he falls down, he scrapes his knee. Now, when that happens, our skin barrier has been infiltrated. So bacteria from the ground can make their way into the connective tissue. This is where they're going to encounter the cells of your innate immune response. And 9 times out of 10, the first cell they're going to encounter is this guy. the macrophage. You probably remember from your Intro to Cells self-study that macrophages are the tissue-resident form of monocytes. They're phagocytic cells originating from the myeloid lineage of the bone marrow. Macrophages are also the garbage trucks of the body. They scavenge the tissue looking for dead and dying cells, and eating dead and dying cells is a great way to encounter pathogens. So macrophages are often our first identifiers of infection. The first major job of the macrophage is to ingest the bacteria, just as I'm showing here with this macrophage that looks kind of like a Pac-Man. This is a receptor-mediated reaction that is covered in the next video entitled PAMPs and PRRs. Once the macrophage ingests the pathogen, one of two things is going to happen. First, all of these purple granules inside the macrophage will go into a vesicle with the bacteria and kill the bacteria. The second thing that's going to happen is that the macrophage will begin producing cytokines. All of these cytokines will be there to promote the inflammatory response. So once again, we're talking about our acute pro-inflammatory triad, IL-1 beta, TNF-alpha, and IL-6. IL-1 beta and TNF-alpha will increase vasodilation and vascular permeability. So basically, they're going to weaken the vasculature such that other cells, blood products, proteins can enter the site of inflammation. IL-6 will begin working feverishly. Get it? Feverishly? Because, that's what it does. It promotes fever. Anyway, bad immunology joke, but that's what it'll do. IL-8 or CXCL8, depending on your nomenclature. Immunologists are kind of mean. We like to name everything twice. But IL-8 is going to promote the recruitment of neutrophils. Remember that neutrophils are our other major phagocyte of the immune system. And the main thing that they do is show up and try to begin cleaning up this mess that the bacteria made. They, in conjunction with a new cytokine that we haven't really talked about much yet, IL-12, will allow for more cells to be involved in this battle. So IL-12 will recruit natural killer cells, which are basically the assassins of the innate immune response. It also promotes development of T cells, part of the adaptive immune response. And all of this works together to enhance the inflammatory response to the pathogen. So now that we've initiated an immediate response to the pathogen, it's time to get on to the third role of the innate immune response, and that's to prime the adaptive immune response. This occurs in a couple of ways. First, we talked about cytokine release already. Cytokines will not only promote your neutrophils and NK cells, it will also promote recruitment of other cells within the adaptive immune compartment. Additionally, it will recruit this guy, the dendritic cell. Dendritic cells are also phagocytic cells. As you can see here, this dendritic cell is phagocytosing the bacteria. But they're a little bit different than your neutrophils and macrophages. After it engulfs the pathogen, it's going to begin traveling to the lymph node. And on its way, it's going to mature. It's going to grow up. And as it grows up, it's going to learn how to do something very special called antigen presentation. When it gets to the lymph node, it's going to present the pathogen that's present at our site of inflammation to the T cells and B cells that reside there. This is the way that it primes the adaptive immune response. And this process, as you might have guessed, is called antigen presentation. This will be covered in a later video. But the main goal of this is to actually initiate the adaptive immune response and invite it to the site of inflammation to basically eliminate the pathogen. So, in summary, there are three roles of the innate immune response. First, provide a physical and chemical barrier. Your skin, while we don't often think of it as an immune organ, provides an incredible barrier that is absolutely imperative for keeping out pathogens. Should your skin epithelium or endothelium become compromised, we move on to goal number 2, initiate an immediate response to the pathogen. 9 times out of 10, that's going to happen because of the work of macrophages, but it could come from other innate immune responses or proteins in the area. Lastly, after that has begun, there's going to be cytokine secretion. Cytokine secretion will recruit more cells, which in turn will lead eventually to the priming of the adaptive immune response. The priming of the adaptive immune response is something that we'll be talking about in much more detail later.